let's apply the soil weight volume relationship into the problem 4, the last problem for the first lessons. An earth field, when completed, will occupy a net volume of 187,000 cubic yards. So basically, that is compacted or filled cubic yard, as you can see, compacted. The borrowed material that will be used, borrow or the one that you go somewhere to buy the material to fill that volume, will be used to contrast this field is a steep clay, so that they give us the material steep clay. And its bank condition, borrowed material has a unit weight of, so we have the wet unit weight, so it means that the general unit gamma, and then the water content, W, for that borrowed material at bank condition, and an in-place void ratio, so we have E 0.620. The field will be constructed in layer of 8-inch depth, loose measure. So basically, before you compact it, you put a layer of soil that you borrow to the field, 8-inch height, and then you compact it. And compact it to get the dry unit weight. So we just see gamma dry for the field material, 114 pound per cubic feet. The moisture content, W, at the field is 18.3%. So as you can see, the water content is changing, and that normally require during compaction, you may need to add more water, etc., to get the optimum dry unit weight, and that cover a lot in Geotech 1, and I'm not going to go into that detail. But the question is, compute the required volume of pit excavation. Compute the required volume of pit excavation. So it means that how much you will borrow or buy material to put that pit. So the question here, as you can see, what is the volume of the borrow? And what is given for the borrow? You give us the unit weight, 129 pound per cubic feet. And as you know, the volume have relationship, gamma equal to W over V. So if they give us gamma, they give us they want us to find out V, we just want to find out what is the weight needed for the borrow. And that is the key. So how can we do? We need to find out what is the fact during this process. So as you can see, during the transformation from the borrow area, the bank, the natural condition, to the field area, the solid part of the soil remain unchanged. You can add more water, which is add the overall weight of the volume of overall weight of the soil, of the material, but the solid part in the phase diagram here remain unchanged during this process, right? Mass conservation. So from that, what we have here is the fact, very important for the fill and excavation borrow problem. We need to know the fact. The fact here is the weight for the solid part at the field location, which is at the site, construction site you built. It have to be the same as the weight of the solid part at the borrow areas, because during that process you excavate, you transport, and you compact it, the solid part remain unchanged. The water may change, you may add more water, but not the solid part. And what given? They give us the field volume. So we have V of the field, and of course they want us to find out the borrow. So basically that you determine how much I need to buy. 187,000 cubic yard. In this case, as you can see, that basically cubic yard, and it to be specific that it compacted cubic yard, right? Because that is fill, it already compacted. And we need to find out we have the equation here, the fact Ws fill equal to Ws borrow. And as I stated earlier, if we find out the solid weight of the borrow material, then we can find out the volume of the borrow pit excavation. So bottom line, we need to find out what is the Ws for the fill and make it equal to the Ws of the borrow. Then we can done for this problem. So for the Ws of the fill, let's go back to what equation in here that have that. So that basically a tri-unit weight. The gamma D equal to Ws over V for the fill, right? Okay, so let me graphically present here what does that mean. So we have a borrow material, borrow places, and then we go to the next location. So basically the fill, and that's transform to here, and they give us the V fill and find out the V borrow. So from here, as I say, we have relationship drive unit weight equal to Ws for V. If we apply for the fill location here, so we have the gamma drive unit weight at the fill location, it equal to, you can hear the gamma for the solid weight equal to what? Equal to W S fill divided by V fill. Everyone agree? And that equation, we have it in here. And now we have the gamma drive of the unit for the fill, 114 pound per cubic feet. And we also know the V fill, so we can find out the solid weight, the weight of the solid part for the fill. So you have it W S fill equal to V fill time gamma drive at the fill location. And we have V fill, volume of the fill, 187,000 cubic yard compacted. Gamma dry fill, 114 pound per cubic feet. So technically you can plug in and can determine the weight of the solid part. And of course that equation, it will be equal to, I just put here, Ws for the borrow location. So with that, we can find the Ws for the borrow, and then we make that equal, we can determine the volume of the borrow. From equation of dry equal to gamma over 1 plus water content. For the borrow material, they give us the wet unit weight, so it means gamma and water content. So you can be able to find out the dry unit weight at the borrow location, and that we have it gamma dry at the borrow. And why we need to find out dry? Because that relates to the weight of the solid part, Ws borrow equal to gamma borrow, the wet including the water, over 1 water content, in this case at the borrow. borrow areas. And if we have, we can plug in that equal to 129 pound per cubic yard. Water content of the borrow 16.5%. So you have 1 plus 0.16.5 point here, and you will get 110 pounds per cubic feet. That is the dry unit weight at the borrow. And when you have the dry unit weight, you can be able to find out the similarly for that equation to find out the WS of the borrow equal to V borrow, volume of the borrow, exactly the same that we did for the fill, time the dry unit weight of the borrow. So from that we can return to the fact the weight for the solid part of the fill equal to the weight of the solid part for the borrow. So we have both, right? We have both. So we have that is 1 and 2. So we can have the go back to the fact. So we have weight of solid of the borrow equal to the weight of the solid of the fill. So basically that we have number 1 and number 2 there. Number 1, number 2, plug in. We have V borrow time gamma drive of borrow equal to V fill time gamma drive of fill, and everything given except volume of borrow that is the question asked. So we have V borrow equal to V fill time the ratio of gamma drive at the compacted fill location over the gamma drive, the unit weight at the borrow location that we change the material from the borrow location to the fill, as I put in the graphic there. So we can plug in V fill 187,000 cubic yard divided by gamma fill drive 114 pound per cubic yard. Gamma drive for borrow we just determine 110, and from that we can have V borrow equal to 192,054 cubic yard, more specific, that is BCY, bank cubic yard. What does that tell us in here? As you can see, we need 187,000 cubic yard to fill. Actually, you need to buy 192,000 cubic yard, and that basically the shrinkage factor we are talking about from the borrow, in this case the natural condition, bank condition BCY, to compacted cubic yard, it going down. So that close for the first lesson we did